Hey everybody, this is Larry. This is day 9 of the Leetcode April Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Verifying an alien dictionary. Another classes day. Verifying an alien dictionary. So I usually do these live, so if it's a little bit slow, fast forward, 2x, skip ahead, watch another video, whatever you need to do. So okay, let's see. In an alien language, they have English letters, but they're in possible different order. The order of the alphabet is some permutation. Okay, you're given the order of the alphabet. Return true if the given words are sorted lexicographically in this alien language. Okay. Okay, so that's not so bad. We just have to see if it's sorted. We have a lookup table, essentially in an order, and then we just we can look for it one by one. So the cool thing is that you only need to look at adjacent words because of the transitive property. I know that it seems like if you're in comp sci and you'll probably notice that a lot of not mathy people say transitive property to sound cool, but this is an actual thing of transitive property where okay, if A is bigger than B and B is bigger than C, then A is bigger than C, right? If the transitive property holds, and this is true, and in a way, and because this ordering is going to be the property holds for transitive property, so that means that we only have to check that A is bigger than B and that B is bigger than C, or if you want to put it another way, words or W sub 1 is bigger than W sub 2 is bigger than, so you only have to look at adjacent words for that reason, so they don't have to do n square comparison. Though in this case n is 100, so it's not that bad, but yeah. And then we look at two adjacent words, and then we check to see if the word that's earlier is lexicographically smaller or earlier than the word that is in later. So that's basically all we have to do. So let's do it. I think there is some implementation thingies about this, but we can do it. So let's look up. Just you go to whatever for index character in enumerate order. Oops. We want to set lookup of C is equal to index. So basically what this does is that it gets the rank, if you will, of the character, and then we put it in a lookup table so that we could look at it all one time. I think if this is 26 characters, we can actually even do better than that. We can actually just have an array of 26 elements, but I'm going to do it this way for now because you would have to manipulate ASCII and stuff like that. But to keep it simple, I'm going to do it in a hash table. But this hash table, of course, is going to be at most 26 characters. So yeah. And then now we just have to go for for word. Let's just say word 1, word 2 in zip of words. Word sub 1. This is a Python shorthand to get adjacent words. So every pair of adjacent words, I want to say it's common-ish in Python. So if you haven't seen it, I'll get used to it a little bit because it does come in handy, and at least in contest, in production code, maybe it's a little bit more sketch, but I think it's still okay because these are all iterators, so they don't actually take that much more space. But anyway, like if you're worrying about it. Okay, so now we have to go if. Let's just have word 1 is greater than word 2, then we return false. Is it false that we have to return? Yep. And then otherwise, if we go past all of them, we return true. And this is greater or equal, I guess, if you want to be precise, because actually no, that's not true. I think greater is fine, because if it's equal, then it's okay. Though I don't know if that it's, yeah, I mean then it doesn't violate the condition. Okay, so yeah, so definitely we declare grade 1, grade 2, word 1, word 2, and then yeah, and then now we just look character by character. Again, we're gonna I mean, we can definitely do the same trick where we get character in word 1, word 2, and then if the lookup of C1 is greater than lookup of C2, we return true. right? Because basically now we're doing a 2 pointers algorithm, and we have to make sure that we go for all the cases because that's not enough. Otherwise, if lookup is less than lookup of C2, then we can already return true. Oh, sorry, we can return false. Otherwise, it's equal. So then we keep going. And then at the very end, what does this mean, right? Well, there are 2 cases or 3 cases. One is, what happened here is that the word is the same up to the min of the 2 words, the length of the 2 words, and then now there are 3 cases. One is word 1 is longer, word 2 is longer, or they're all equal size. If they're equal size, then it is false, or if word 2 is longer, it's false. So we just have to, this is true if length of word 1 is greater than length of word 2. I think that's the case. That's why we have to write test and double check. But yeah, so now we just have to put in more test cases. This looks good, but one thing I would also say when you're testing, especially in competition, one thing to notice is that this output is in binary, right? It's true or false, it's Boolean. And what I mean by that is that sometimes you can get quote unquote lucky and it matches your answer, even though it is a wrong answer. So you have to be careful about it. This actually, those one of the cases that I would have etched. But yeah, but this looks okay. So let's give it a submit and cross fingers. Cool. Yeah, what is the complexity of this, right? Well, this for loop is going to be O of n, where n is the number of words, because you can think about it as just having 2 pointers and they move together. So that's going to be O of n in terms of number of loops. And in this greater function, just also linear in the length of the word. So that's going to be, each word is, or each character in each word will be looked at most twice. Once to compare to the word before, and another time to compare to the word after. So in that case, you can kind of do the summation or amortized or whatever to get to say that this is linear in the size of the input, where the size of the input is not just n, is the number of characters, right? Where n may be the number of words, but the number of characters is roughly n times m, if you want to call it that, where m is the length of the longest word, but the words can have different lengths, which is why the phrasing is very precise. And it's linear in the size of the input. And of course, as I mentioned before, this is constant because there's only 26 characters. You can also say it's O of alphabet, if you will, in that it is, with the or O of the size of the alphabet, which is O of alpha, maybe, depending on which letter you want to use, where alpha is the length of the alphabet. So if you have uppercase now is 52 characters or so forth, right, in weird order. So yeah. So everything is going to be linear time. Do I use any space? No, I mean, other than this is constant space. So yeah, linear time, constant space, and that's all I have. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Hope y'all have a great weekend. And yeah, stay good, stay healthy, to good health and to good mental health. I'll see you tomorrow. Bye bye.